11.1 3D Basics and Spheres. In 3D coordinates, we have an X, Y, and a Z coordinate system. Customarily, we do X and Y in the horizontal plane, Z in the upward direction. We generally have X here and Y here. If we let our fingers go from X to Y, our thumbs will point in the Z direction. That gives us a right-handed coordinate system. If you reverse X and Y, put X here and Y here, it actually gives you a left-handed coordinate system. We're not going to do that. It's certainly possible, but a lot of our vector conventions will depend on us having a right-handed coordinate system. Europe, they use a left-handed coordinate system, but here we don't. To start off, let's suppose we have the point 2, 3, 4. You can sketch this very easily by sketching 2, 3 in the XY plane. Go over 2, over 3, plot the point. Okay, this 3 is misplaced actually. We'll move that over a little bit. And that's the point 2, 3, 0. Anywhere in the XY plane, the Z coordinate is 0. And then you have to go up 4 units. This is up 4. There's 4 on the Z-axis. Okay, these two lines should be the same length and parallel, and that takes us upward to here, and we've taken care of their perspective, so to speak. If we want to know the distance from the origin to here, this is a right triangle, we can simply use the Pythagorean theorem. This horizontal displacement is actually square root of 2 squared plus 3 squared. That's just the two-dimensional Pythagorean theorem. And then the vertical distance is 4. We know the two legs, so we can figure out the hypotenuse. D squared is that squared is this, and 4 squared is this. And so D is the square root of 2 squared plus 3 squared plus 4 squared. It's a three-dimensional Pythagorean theorem. Here's a distance formula. It doesn't take too much imagination to generalize this. The distance from P0 to P1 is just square root of x1 minus x0 squared plus y1 minus y0 squared, and same for z. We can generate a sphere equation up here. It's not too difficult. We just take the center x0, y0, z0, and you can draw a sphere. A sphere is merely the sum of all points, distance r from some common center. And this could be some general point x, y, z. Well, if you apply the distance formula to these points with a radius r, you can generate this equation quite simply put. It looks like a three-dimensional circle. High school, you go through all the circle coordinate geometry. We just have to add a coordinate. There's also three simple planes we'll talk about. X equals a constant is parallel to the YZ plane. Here's the YZ plane. If you had X equals 2, for instance, it would go through this 2 right here, and it would give you a plane out from the whiteboard 2 units. Y equals C parallel to the XZ plane. So Y equals 3, for instance, it would give you a plane going in this direction. And Z equals C parallel to the XY plane. That would be a horizontal plane. And we'll sketch a few of these as time goes on. Here's a fairly simple problem. Let's find the equation of a sphere with center 2, 3, 5, and including the point 3, 4, 8. Well, once we have the center, that tells us that x0, y0, z0 is 2, 3, 5. And so we could at least partially fill in our sphere equation. And all we're missing is r. Well, r is just the distance. It's going to be the distance from this point to this point. And so we have 3 minus 2 squared plus 4 minus 3 squared plus 8 minus 5 squared. And that's 1, and that's 9. So we get square root of 11. And all we have to do is put this number back in here, and we have the equation x minus 2 squared plus y minus 3 squared plus z minus 5 squared equals 11. And that's our sphere equation. Problem number 2, let's suppose we have x squared minus 2x plus y squared plus 4y plus z squared equals 5. And this is a sphere equation. As long as we have 1x squared, 1y squared, 1z squared, it's definitely a sphere. It's not anything else. And the question is, what's the center and radius?